Hello guys, welcome back to MJ School of Mining and Geology. In today's session, we are dealing with the three main school of thoughts. These are nicknamed the uppers, the downwards, and the offstage school of thoughts. So I wonder if you ever wondered how metals like platinum got trapped deep underground in places like the Bushveld complex in South Africa. So geologists have few ideas, and today we're going to explore these ideas. Like I said, they're nicknamed the uppers, downers, and the offstage school of thoughts. All these they were responsible for the PG enrichment, okay, in the Merensky Reef of the Bushveld complex within the critical zone. But don't worry, I'll keep it simple. Even if you've never taken a geology class before, you're gonna understand this school of thoughts. But I'm sure you know what I'm going to say. Please don't forget to like, share, comment, and hit the notification button below so that you get notified once we upload new content. So, say for instance, you are not familiar with the layered intrusions. All right. So Bushveld complex is one of the layered intrusions that happened in the world. All right. But because the Bushveld complex, it has got, the good layerings and the enrichment of the metals within the Bushveld complex, it's and also because of its size, all right, the Bushveld complex is used as the frame of reference. It means everyone who wants to understand better the layered the formation of layered intrusions, they're using the Bushveld complex as the frame of reference. So basically, Bushveld complex is 2.054 billion years, and it hosts what you call the Rustenburg layered suite. The Rustenburg layered suite, if you're not familiar with it, it's the largest known layered mafic intrusion, and this represents the largest magmatic ore resource in this world. And of course, um, platinum is renowned to be containing large quantities of PGEs, chromium, and the vanadium. So, for example, here these are the layers of the chromatides that we see in the Bushveld complex. All right, so it means that the Bushveld complex, it contains chromium, and it also contains the vanadium and the magnetite that we see in the upper zone. All right, and then also the PGEs that are found within the Merensky Reef. All right. So, but for over 9 years, the Bushveld complex has been the subject of continuous research since researchers have discovered the PGE mineralization, and it is estimated to contain approximately 75% of the world's PGEs. But there is no general agreement. All right, there is no general agreement when we're looking at the nature of the layerings and also the processes which are related to the distribution of the PGEs or the PGE mineralization as to whether these it happened due to the magma mixing, whether it happened due to the effect of contamination and assimilation, or it happened because of or the processes which could have brought what you call the sulfur saturation. All right, so there is no general agreement in the Bushveld complex, which is why we still have ongoing researches that are taking place in the Bushveld complex. But according to Gruger, the Bushveld complex was emplaced as seal-like sheets. We know the traditional um, understanding of the layered intrusions was through what we call the fractional crystallization. fractional crystallization. You'll agree with me that any first year student, they were taught of fractional crystallization. Okay, so that is the normal way of the how the Bushveld complex was interpreted back in the days. All right, but now studies like Gruger and other recent researchers, they see the Bushveld complex as the magma, which was like ascend and then get to be in place. There comes another one, ascend, get to be in place in the form of seals like in placement. All right, and these seals like in placement on its own, it's also the model. It's also the model which has been, now it has gained the world's attention. The seal like in placement. All right, because this when we're looking at the in situ or mineral specific data, it shows that the for example, in the northern limb, the when you're looking at the flat reef, for example, it shows that the units which are stratigraphically higher, they've got high contamination as compared to the units which are stratigraphically lower, that they are in contact with the footwall units. So it shows that these units or the units of the flat reef or of the Bushveld complex, they were placed in a form of seal-like emplacement, which is why we still expect, all right, or we still see, observe the highest contamination in the units which are stratigraphically higher from the footwall units. Okay. So this model, it also gains the world's attention. And um, it was, as seals between the volcanic rocks of the Riebeck group, and these volcanic rocks form the uppermost unit of the late Archean Transvaal supergroup and represent one of the largest silicic volcanic provinces. We know that the Rustenburg suite, for example, we had the Riebeck group. And the Riebeck group is divided into the upper Riebeck and the lower Riebeck. So we've got the lower Riebeck group, lower Riebeck group, lower Riebeck group, and the upper Riebeck group. So the upper Riebeck group, we've got Schrikloof, Damval, and others. All right, there are three. And then we've got the lower one. All right. So what happened was these are the three. One, two, three. So these three, the upper Riebeck group. So what happened was the Rustenburg magma, the, the Rustenburg Layersuit magma came and then get to be emplaced here. Okay, it was emplaced here. Okay, between what? Between the lower Riebeck group and the upper Riebeck group. So now it means that the upper Riebeck group, Damval, Schrikloof, Kogasnek, all these things, they are the roof of the Rustenburg Layersuit, and then but the floor of the Rustenburg Layersuit is now the lower Riebeck group. All right, the lower Riebeck group, which is what you call the Dalstrom. All right, the Dalstrom. And then also the Transvaal supergroup. So the Transvaal supergroup rocks and the Dalstrom, they serve as the floor of the Rustenburg Layersuit. Okay. So south of what you call the Tabazimbi Murchison lineament, I'll show you this fold. Okay, the Rustenburg is thought to cover a vast size greater than 66,000 square kilometers. Okay, with this volume. So this is the greatest size ever, which is why the Bushveld complex, it's used as the natural testing laboratory. Okay, so it means everyone who needs to understand the petrology and the genesis theories, they're using the Bushveld complex as the frame of reference because of this enormous aerial extent. But the in 2013, Lombeck was like, no, we don't know the extent of the Bushveld complex north of the Tabazimbi Murchison lineament, that is to say, in the northern limb. But now, the geophysical data by Finn et al. In 2015, it indicated that north of the Tabazimbi Murchison element, that is to say, in the northern limb, the Bushveld complex, it covers the areal extent greater than 90,000 square kilometers. So now making the Bushveld complex to be having the vast areal extent, and that's why it is used as the frame of reference. It means everyone who need to understand the genesis theories, they use the Bushveld complex as the frame of reference. Okay. Then moving right on. If you are not familiar with the Bushveld complex is divided into the northern limb. Okay, this is that Tabazimbi Murchison lineament. So we say north of this and south of this. North of this, the Bushveld complex covers the areal extent greater than 90,000 square kilometers. But below, that is to say, the northern limb, it has got areal extent of greater than 90,000. But when we're looking at the western limb, when we're looking at the western limb, that is to say Rustenburg, and then also in the eastern limb, wherein we're looking at with the Beggersford, and these and also the far western limbs and the southern limb, all right, which southern limb is hidden below the surface, all right, because of the sedimentary rocks. We do not the areal extent below this Tabazimbi Murchison is greater than 66,000 square kilometers. So the Bushveld complex is divided into 5 limbs: the northern limb, far western limb, western limb, southern Bithal limb, east and eastern limb. All right, and we see a lot of mining activities that are taking place in the western limb and also in the eastern limb. But now, here in the northern limb, we also have now, I think this year, in the Makalakascope, where in the Ivan Platz, they are mining what you call the flat reef here. And then also the Blood Reef, now it has been mined. It was being mined in the mine called Mogalakwena, right here in the northern limb. So, and then here we also have got Waterberg. Here we've got Waterberg project here. Okay, we've got Waterberg project here. All right. So we've got a lot of activities, mining activities that are now taking place in the northern limb as well. But now, if we're looking in South Africa, so we can see the Bushveld complex is happening towards the north, okay, towards the north of the southern Africa. All right, and then the Bushveld complex is subdivided into main suites, that is to say the Rustenburg lead suite, which is mafic, all right, and the Leboa granite and the Rashub granophyre and then some of the authors, they say the Rieber group, it's a precursor to the Bushveld complex, and some they associated them, but not according to Sachs 1980. Sachs 1980, it does not include the Rieber as part of the Bushveld complex, but there are some studies which are saying probably the Rieber group is part of the Bushveld complex. Okay. And then now, yes, we've got this fold as well, plank neck fold, and then we've got also this Tabazimbi, and we also have got the Zibidiela fold, all right, in the northern limb. Now, the mafic or ultramafic components, that is to say the Rustenburg lead suite, all right, it is subdivided into the zones. We've got the marginal zone, we've got the lower zone, the critical zone, which is the most mineralized one. The most mineralized one is mineralized in what you call the UG2 and the UG2 and also the Merensky Reef. That's the Merensky Reef. That's where we are finding the PGEs and the chromium contents. Okay. And then the Rustenburg suit is thought to have been emplaced below the Rieberg felsites and the Rashub. So, and the PGE mineralization in both eastern and western limbs occurs mainly in the critical zone. In the critical zone, all right. The mineralization occurs in the form of relatively narrow stratiform reefs, all right, that are usually within several decimeters, that are located several kilometers above the base of the intrusions. But now the mineralization in the northern limb occurs in the critical zone, as I've mentioned, so the same as in the other limbs. That is to say, for example, when we're looking at the northern limb, okay. But when we're looking at the northern limb, the lower zone is relatively undeveloped, also with the together with the marginal zones, together with the marginal zone. Okay, this makes the mineralization to occur at the base of the complex in the form of contact style mineralization, especially in the northern limb. That's why the northern limb is highly contaminated as compared to the eastern and western limb, and the reason being is because of the relatively undeveloped lower zone and the marginal zone, making the critical zone to in places to abut or to sit on top of the food wall rocks. That's why the northern limb is highly contaminated as compared to the the eastern and western limbs. Okay, but now if we were to look at the stratigraphic correlation, okay, some studies they've correlated eastern, western, and the northern limb. Okay, so like I mentioned that despite localized stratigraphic differences, the northern limb of the Rustenburg suite uses similar zonal subdivision as the eastern and western limbs. Just that some of the units they appear in eastern and western limbs, and some they appear only in the northern limb. Okay, so we know that for example, in the northern limb, okay, in the northern limb, we do not have remember the critical zone. The critical zone is divided into the upper critical zone and the lower critical zone. In the eastern and western limb, we also have got this, the lower critical zone and the upper critical zone. And in the upper critical zone, that's where we are having the UG2s and the Merensky Reef, wherein we are finding the PGEs and the chromiums. Okay, and then in the lower chromatide, lower critical zone, that's where we are finding these. Okay, within the LG1 to LG6. All right, and then we also have got the Mg metal groups. Right, so in the northern limb, this lower critical zone, it appears to be absent. All right, but the upper critical zones, now it's typically correlated with the blood reef. All right, you can see here is the critical zone is divided into upper critical zone and the lower critical zone. So in the northern limb, it appears to be absent. That's why if we were to track this on this side, we don't see it. It means it appears to be relatively absent. All right. But now the upper critical zone, now it has been correlated. You can see it has been correlated with the blood reef by so many studies. For example, Grobler et al. 2019. All right, they're correlating the blood reef with the critical zone. All right. So this northern limb is significantly more contaminated, and it is enriched in sulfides as compared to the eastern and western limb. right? But it is relatively depleted in chromite. Okay, according to the style by by studies by Meyer et al. 2019. But so the critical zone, it outcrops. You can see it outcrops in the northern limb. And then where it outcrops in the northern limbs, it has a thickness of up to 400 meters. 400 meters. Okay, in the northern limb. But this critical zone in the northern limb, okay, at the same stratigraphic position as the blood reef, we've got what you call GNPA member. Okay, this is this GNPA member. It's also termed the critical zone according to the studies by Van der Merwe 1976 and Hulbert 1983. Okay, and then they say it consists of the interlayered orthopyroxene. It consists of interlayered orthopyroxene, um, chromite, clinopyroxene, and plagioclase cumulates, okay, which are approximately 400 to 800 meters in thickness. And this GNP member is found in on the farm Grass Valley. Grass Valley is somewhere south of that fold that I showed you. That is plank neck fold. South of that, all right, on the farm Grass Valley, that's where they found this GNP member. Studies by Smith et al. 2016. They found this. All right. So this GNPA member is at the same stratigraphic position or level to what you call the blood reef. So it means now the blood reef and the GNPA member, they are both termed the critical zone. But now the Ivanhoe Corporation, when they were drilling, okay, on the farm Macalacascope and the turf spread in the northern limb, they also discovered the extension of this blood reef down deep, and it was termed what you call the flood reef. Flood reef. It means critical zone, okay, in the northern limb is blood reef, flood reef or flat reef, and of course GNPA member, all right, in the northern limb. So this upper critical zone, it's correlated with these units, all right? Okay, I hope you understand. But marginal zone, you can see it's sometimes it's also relatively undeveloped, or sometimes it's absent. And where it's absent, you see now, and remember I said the lower zone is relatively undeveloped. Sometimes it's absent, right? But because it's thinner, sometimes you'd find the critical zone in the northern limb sitting right on top of the footwall units, that is to say the Transvaal and the Achaean granites. Right, and these are the major source of contaminations in the northern limb, which brought about the sulfur saturation in the northern limb. They are the ones which were proposed to, bring about the PGE mineralization in the northern limb. Right. So, but we also see now what you call the troctolite unit. We also see the troctolite unit in the main zone in the northern limb, but we don't see this troctolite unit in the eastern and western limb. All right, these are some of the things that they are lacking in the eastern and western limb, but they are there in the northern limb. But no, we also see in the main zone. So in the northern limb, the main zone is significantly thinner. compared to the main zone in the western and eastern limb. Okay, this was proposed by Wagner 1929. All right, but the study by van der Merwe 1976, they noted that the well-known pyroxenide marker, this PM, okay, van der Merwe. The study by van der Merwe 1976 shows the well-known pyroxenite marker in the eastern and western limbs, which correlates to a pyroxenite horizon that is located around at around 2,000 meters above the base of the main zone. Okay, above the base of the main zone. So somewhere here, so above the base of the main zone, just you go up a bit, and then at about 2,000 meters above the base of the main zone, that's where we also see the pyroxenite marker. It means the pyroxenite marker is there in the eastern and western limbs, and also in the northern limb. I hope you understand. And then let's see what we see in the upper zone. So we know in the northern limb, the upper zone is rarely exposed, okay, and is primarily studied through the borehole data. All right, it was studied through the borehole data by this has been shown in the study by Smith et al. 2016. Okay. So the upper zone, in the upper zone, we know it's characterized by the first appearance the first appearance of the first appearance of the new cumulus minerals inside the layered sequence, right? So this is defined by the first appearance of the titanium-rich magnetite. If you can see here, magnetite layer. Also in the north, this has been seen in the northern limb, and also in the eastern and western limb. Then the upper zone is marked by the appearance of titanium-rich magnetite layers. That's where we are getting the iron from in the northern limb, and also in the western limb. Okay. So I hope this correlation, it makes sense. And the new studies, they are still trying to correlate the upper critical zone with the flat reef, the flat reef or the blood reef. Okay, the sulfur isotope studies and the whole rock sulfur isotope. Okay, the in situ sulfur isotopes and the whole rock sulfur isotopes. There's still ongoing research wherein people are trying to correlate the upper critical zone. All right, the upper critical zone, main zone transition in the eastern and western limb with the northern limb. Okay, with the blood reef or flat reef in the northern limb. Okay. I've already mentioned this. Okay, that we can correlate the critical zone is basically the upper critical zone is correlated with the GNPA member. Okay, with the GNPA member. All right, this is the correlation that I wanted to understand. And the study by Gruger proposed that the blood reef is analogous to the Merensky Reef in terms of stratigraphic position. And also this has been supported by studies by Gruger et al. Not Gruger, but Hrobler et al. 2019. All right. And then now the studies shows that the upper critical zone is it can be correlated with the blood reef or flat reef in the northern limb. Okay. Now, you understand the school of thoughts. All right. You understand the school of thoughts. This school of thoughts, there are three. We have got the downers, we have got the uppers, and we have got the what do you call the off stage. Okay. So I'm going to take you through these methods. Now you are familiar with the Bushveld complex, okay, its limbs, and now we want to understand the mineralization of PGEs. Which models best support, or let me not say best support, but the models which have been proposed to, to come about the development of the PGEs in the Bushveld complex. Okay, I've got the downers. Okay, the development of the model called the downers. Okay, so we've got the turbulent mixing. Okay, which suggests that the reef formed as a result of large-scale turbulent mixing. There was in the magma chamber we had turbulent mixing. That is to say, where's my pen? Okay, we had this turbulent mixing. We had this turbulent mixing in the magma chamber. Okay, we had the turbulent mixing. Okay, between the resident and newly injected magma. So it means that the new magma was coming into the magma chamber, leading to the settling of immiscible sulfide melts, droplets, and chromite crystals onto the temporary chamber floor. It means now, if we had the magma chamber like this, after this turbulent mixing, okay, because of the new magma into this chamber, it brought about the liquid immiscibility, and then now these things, they settled at the bottom of this magma chamber, okay, forming the PGE nickel copper deposits. But we also have got lateral mixing models, okay, which propose that new magma was placed as basal flows along the chamber floor, promoting interaction with the resident magma and facilitating sulfide and chromite deposition. Okay, but Ginat also introduced a different perspective, suggesting that contamination from granophyric roof rocks played a role in this model. Melts from the roof rocks were entrained by a fountain-like pulse of magma entering in the magma chamber. All right, entering the magma chamber. Come in. All right. So, come in. Um, um, um. So what do we see? What do you see? This was when these people are still developing the downers school of thought. Can you now see that all these three, and we're still going to add more other theories, which all of these things, they are showing that the new magma, it promoted the liquid immiscibility, and then after that, we know we've got the PGEs, the PGEs, nickel coppers, they are chalcophiles. They like to be, they are like magnets. We know the sulfur droplets, they are like magnets. So when they're going downward, they're going to be incorporating them. They're going to be incorporating or attracting the PGEs, nickel, and coppers. Okay. So, and then Cawthon argued that the magma mixing is not essential for achieving sulfur and chromite saturation. Okay. So now, instead, he proposed that a transient increase in pressure through the magma chamber caused by injection of basal magma influx could trigger saturation. So the study by Cawthon, 2005 and 2011, says, man, no, remember the previous studies that I've just mentioned previously, they we're talking about the new magma bringing in the what you call the sulfur saturation, right? Now, but this study, it says no. I don't think magma mixing could have, was the essential factor. Rather, I think the effect of the increase in pressure could have brought or could have triggered the sulfur saturation or sulfur chromite saturation. Okay, so building on this, Latipov suggested that no, the Merensky Reef formed through repeated basal magma inflows that thermochemically eroded the existing cumulate pile and crystallization in situ on the chamber floor. They further proposed that the chromite and sulfide melt crystallize in place, scavenging PGEs from the overlying magma during episodes of vigorous thermochemical convection. But all of these studies, they have got a common ground. It means the models, they share a common feature. That is to say, the introduction of a new magma or multiple magmas into the magma chamber at a level above the immediate chamber floor. This process is thought to have triggered the sulfur saturation, either through magma mixing or increased chamber pressure. So we are combining what Cawthon and other studies like Letipov and the Kinnert et al. 2002. All those studies, in combination, they show that either magma mixing or the effect of increased pressure inside the magma chamber could have triggered the sulfur saturation or chromite saturation, which now could have this model they could have brought a significant amount of PGEs within the Merensky Reef. Okay, so now in the end we've got them. They now developed all these the studies that I've mentioned. They wanted to come to it came to one school of thought, which is the downers. All right, the downers, it shows that the metals were dragged downward. The metals were dragged downward. It means inside that magma chamber, if you were to close your eyes, you imagine the droplets of sulfur. These droplets of sulfur, because they were having high density inside the magma chamber, so they were going downward. But because we know we have got chalcophiles, things which they love to be attracted to sulfur droplets, such as PGEs, nickel, copper, and many others, they were attracted to these sulfur droplets as they were going downward. As the sulfur droplets were going downward, and they were deposited at the bottom of the magma chamber. This is the what you call the Downers school of thoughts. That's why we say in the Downers school of thought, which posits that PGEs were concentrated at the base of the magma chamber, having been scavenged from the overlying magma column and deposited onto the chamber floor. And this was shown better by the Naldred et al. 2009 and I think also 2008. Okay. And I'll show you the model of these downwards and the uppers in a few. But on the other hand, the uppers is the opposite of the downers. Okay, so the uppers, it means the metals are being pushed upwards. So in this idea, hot salty fluids which are rich in chlorine, like mineral steam, rise up from deep below. All right. So as they rise, they carry metals like platinum with them. So when they hit a layer of molten rock, all right, or magma, they release these metals, and those metals, they stick to sulfides. All right. They stick to sulfides because they are chalcophiles. They love to be attracted to sulfides. Okay. These sulfides are like tiny mineral magnets. So as a result, a rich layer of metals right at the boundary between the rising fluid and the molten rock, they gave us these PGEs. Okay. So yes, before I get into the offstage model, let me show you these models. So can you see that the downwards, it shows that with downwards, it shows that after mixing of new and old magmas, okay, occurs in a turbulent plume causing sulfide immiscibility. Now, after we're having sulfide immiscibility, it means we are separating. Remember, it was a magma like this magma. We're having the sulfide with the silicate magma. Okay, all occurring within one thing. But because of the effect of liquid immiscibility, then now there was separation. It means we had now the sulfide phase, and the silicate phase. Then now this sulfide phase in the form of droplets now, ne? They were going downward because of the effect of density. Then when they were going downward, okay, when they were going downward, they were going in with these droplets. When they were going downward, they were attracting PGEs that they found down. Okay, as they were going down, they were attracting nickels, they were attracting copper as they were going downward, because these things that are chalcophile, they allow to be associated with sulfur. Then now they're going to form, as now when they're going to settle, they formed the PGE nickel copper deposit at the bottom of the magma chamber. I hope you understand. And the opposite is the uppers. All right. Then the uppers, it shows that we had the with the uppers, the upper school of thought maintains that the metals, okay, the metals have been concentrated from the underlying cumulates by ascending chloride-rich fluids and have been released at the cumulate magma interface, where accumulating sulfides fixed the metals in situ. So that's the theory of the uppers. That is the theory of the uppers. It means now the uppers model calls for the upward percolation through the foot wall cumulate pile of a chloride-rich aqueous fluid, capable of striping or dissolving. Oh, sorry guys. The network. It was because of the network. So yeah, I hope you understand. Now we've got the recent school of thought. Sorry about that. That was the issue of network. So it went off a bit. So we have got the recent school of thought. Okay. It's termed off stage. This has gained attention in the past decade and is still continuing to, to gain the attention. So this model suggests that the PGE concentration in the Merensky Reef did not occur within the main Bushveld magma chamber or magma chambers, but rather it happened within the staging chambers. Okay, it happened within the staging chambers. This model has been supported by the geochemical evidence, which were done by the listed studies. Okay, and the further support is provided by recent geophysical interpretations, including the 3D gravity modeling and seismic receiver functions, which image dense material at the crust mantle boundary beneath the Bushveld complex, okay, by Cole et al. 22 and 24. These findings suggest for the first time the existence of deep-seated magma staging chambers that underlie the entire complex and extend westward into the Botswana Smallhopos Farms complex. These new findings have also renewed scrutiny of long-held assumptions about the formation of the Rustenburg-Leer Strait. Okay? So and we've got just that it's not yet published, but the in situ data in the Bushveld complex in the northern limb, all right, by Malabati Johannes, in the northern limb, the in situ sulfur isotopes, all right, both Cap 33 and sulfur 34, they show that indeed they support that indeed we have got the contamination which triggered the sulfur saturation. It happened in the deep staging chamber. All right, but I'm going to explain what do we mean by that. I'm going to explain what do we mean by that when I'm going to be showing you some models. All right. So basically that is that. This it shows the enrichment of magma through the dissolution of sulfide in a staging chamber. So the study by Kinnett, this model was proposed by the study by Kinnett or or Kinnat, Judith. Okay. So what happened? This is the most interesting because um, the studies, okay, they show that the staging chamber model explain how PGE-rich magma with a low copper to palladium ratio could have formed before reaching Bushveld complex main magma chamber. Sorry. So an early batch of magma, it enters there. This is the early batch of the magma, okay, from the mantle. So it enters the deep staging chamber, for example, this one, okay, and drops off the sulfide minerals. So we dropped off the sulfide minerals. These sulfide minerals, they act like sponges for metals, okay? They attract the metals. So later on, magmas that pass through the remember already in the staging chambers, the first batch of magma, it dropped off the sulfide minerals. And remember, sulfide minerals, we know PGEs, they like to be attracted to sulfide minerals. Okay. Then the second batch, now when they pass through this chamber, for example, they are now undersaturated with sulfide. They do not have sulfide. So they interact with the older sulfide that were brought in by the first or early batch of magma. So this, they mainly dissolve out the ion. So they took ion, and then that ion, it was attracted to the sulfur. This process leaves behind sulfides that are enriched in precious metals like platinum and palladium. Because of now, a lot of iron, it has been attracted to these sulfides. And then now, lot of PGEs now, they were left behind. Okay. Eventually, one of the last pulses of magma, the one that formed the Merensky Reef, may have picked up the remaining metal-rich sulfides, becoming extremely enriched in PGEs. That is this. That's why we have got the high concentration or high metal of PGEs or high PGE content in the Merensky Reef as compared to in the Bastard Reef overlying this Merensky Reef. Okay, I hope you understand. But now the geochemical evidence. Okay, the geochemical evidence, it supports the offstage model. Okay, we the studies, for example, the in the northern limb. Okay, in the northern limb, we see the studies by Kiet et al. 2021. Kies Saj et al. 2021 as well. Okay, they've done extensive sulfur isotope to support this offstage. All right, they support this offstage. But now, how did they come to the conclusion? Okay, using sulfur 34. Okay, using sulfur 34 isotopes. So they got the the sulfur 34 values which were ranging let's say from because the study by Kiet it mentioned the fact that Merensky Reef, it has got sulfur 34 which ranges from 1.1 to, no, not 1.1, but 0.2 to 0.2 to 1.5. Merensky Reef, it has got 0.2 to 1.5. All right. But the study by Kearsarge shows that Merensky Reef, it ranges from 1.5 to 3.8 per meal. Okay, per meal. So all these studies, they 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 showed the less contamination. They interpreted these values to be of mental-like signatures. It means that they are relatively consistent and moderate, they are relatively less contaminated. Okay, so their studies showed that the PGEs enriched the PGE enriched Merensky Reef was not significantly contaminated by the local food wall lithologies, for example, by the Transvaal supergroup food wall rocks, such as the dolomites and shales. They said, no, it's not because of that. Okay? Rather, this shows that the sulfide saturation occurred prior to the emplacement into the Rustenburg-Laird stratigraphy. It shows that sulfur saturation it happened in the deep staging chamber, because now these their values, they are mental like signatures. It shows that it has got these mental like signatures, and mental like the lithospheric mental below the Kapval criterion, it ranges from negative 1 point this value to positive 2.4. Okay, this is the lithospheric mantle below the Kapval craton. And then also the recent studies. Okay, but let's not say recent, because here now we are in 2025 and this is 2015. So if you say recent, it's somehow. But let's say the study by Labidi, it shows the first ever mental like signatures, mental signatures which are more negative. Okay, negative 2 to 0. So it shows now the baseline for the mental signatures. Now it will be from negative 2 to 2.4. This is the baseline for the lithospheric mental. Okay, so now it means all these values that are overlapping with mental signatures, it shows that contamination, it happens deeper in the crust. It shows that saturation, sulfur saturation, occurred prior to the emplacement, prior to here. This it supports the offstage signatures. Okay, and like I said, the study also, but it's a MSc study, so it's not published. But the study also it observed the mental like signatures, sulfur 34 values, which are within the range documented by the study by Kiet et al. 2021 and Kiesage, and are also within the range of the lithospheric mantle. It shows that now that contamination it happened, or the sulfur saturation, it happened deep in the crust rather than during the emplacement. But now, also, these, remember some studies, they showed that if you couple sulfur 34 with cap 33, which shows the MIF signatures or mass independent fractionation signatures, if you couple these things, then you can have the better understanding of the offstage. Okay, so to introduce you to these MIF signatures or mass independent fractionation. Okay, if you haven't yet visited our video on mass independent fractionation, you're more than welcome to visit that on the MJ School of Mining and Geology YouTube channel. We also dealt with the MIF signatures, but the MIF of sulfur isotopes is a hallmark of Archean surface environments prior to great oxidation event around 2.45. We know great oxidation event happened at 2.045. So it means the MIF signatures, they show surface Archean surface environments. Okay. As a result, any detection of non-zero or MIF signatures in younger magmatic systems like that of the Bushveld complex, which formed after the great oxidation event, implies assimilation of sedimentary sulfur derived from Archean sources, which happened deep in the crust. because the Archean are the oldest rocks, and they happen deep in the crust. So it means if we observe these myth signatures in the Bushveld complex, it shows that now the contamination is not because of the Transvaal supergroup foothold rocks, but it is because of the Archean reservoir. And indeed, the MIF signatures, they were reported, or these zero signatures, they were reported in the northern limb. They were reported in the northern limb, especially also by the study this has been published, claimed et al. I think it's 20. Is it 2020? I think it's 2020. Is it 2020? I think it's 2020. Yeah, if I'm not mistaken, I think it's 2020. Okay, 2020. Yes. So this study shows the myth signatures, and also the study by you forgive me, guys. I don't know how to pronounce this, but let me just write it. The study, it's written Maga. I don't know how you spell this. Et al. 2018 shows also the MIF signatures. She also shows the MIF signatures. Okay, so it shows now also, like I said, now the MSc studies or study the in situ multiple sulfur isotope. Okay, it also shows these the MIF signatures. Okay, in the northern limb. It also shows these MIF signatures in the northern limb. So now it shows that indeed the sulfur saturation it happened, or the contamination or assimilation which brought about the sulfur saturation or liquid immiscibility. It happened deep in the staging chamber before the emplacement of the critical zone in the upper crust. I hope you understand. If you struggle to understand these models, please, you are more than welcome to or comment on the comment section, and I'll be pleased to, elaborate further should you struggle to understand these things. But like I said, I put these references so that if you want to do further reading, you are more than welcome to also visit these references that I've just listed, and you can also read even more to, equip yourself. So beside these models, we also have got the other models. Okay, the models proposed by Michel and Schoon, and Gruger and Meyer and Mungal offer alternative explanation for the formation of the reef or the Merensky Reef horizon and associated mineralization. So these models incorporate elements of magmatic processes, crustal dynamics, fluid flow, often involving hybrid mechanism. As such, they do not fit neatly into any of the three conventional school of thoughts. Instead, they highlight the complex interplay of multiple geological processes. So we've got the ceiling placement. Okay, we've got the ceiling placement. This ceiling placement, it's another model. So these studies, they propose that Merensky Reef was in place as a seal into the pre-existing cumulate pile. Like and this, it also the in situ multiple sulfur isotope in the northern limb also supports this, because we saw the high sulfur 34 values in the bastard reef of the flat reef, the bastard reef fasces of the flat reef. All right, and shows that okay, indeed, the Bushveld complex, it was not these challenges the traditional way of Bushveld formation that it formed in the form of it formed sequentially, but now it formed in the form of seal emplacement. So Gruger argued that the intruding magma was derived from a main zone lineage and was in place beneath and already formed bastard reef in the form of seals. Okay, Michel and School further suggested that Merensky Reef, along with many of the thick lateral extensive chromatite layers of the critical zone, were in place sequentially as cells. These cells, along with the intervening layers, show evidence of evolving composition over time, indicating simultaneous yet distinctive magmatic evolution during magma emplacement or during the Merensky Reef emplacement. Recent sulfur isotope studies of the flood reef of the northern limb support a seal emplacement model for the Bushveld complex. As I've mentioned, these are the in situ data. Kiet et al. Presented evidence consistent with this interpretation, and in situ data from Malvo Johannes. This is the MSc. This is the MSc study, but it's not published. So yeah, but at least it contributes as well. And then we've got the out of sequence seal emplacement. This out of sequence, it shows that, remember, what do we expect? We expect that we have the marginal zone. We expect the marginal zone. After marginal zone, we expect to see the lower zone. After the lower zone, we expect to see the critical zone. The critical zone, we expect to see the main zone and the upper zone. That's what we expect. But this out of sequence, it shows that no, these things, they were not formed sequentially like this. Okay, you find that this main zone came before the critical zone, like that. So this out of sequence, it was based on the study by the Zircon dating, which proposed that the Merensky Reef is younger than the main zone. Okay, implying that it was not in place as a seal into already crystallized mafic rocks. Okay, so it was not formed sequentially. It shows that the Bushveld complex, it was not formed sequentially, but rather it formed in the form of seals like emplacement. Also, the studies by Scotes et al. 2021 reported out of seal crystallization ages. However, these interpretations remain controversial as they appear inconsistent with the observations in the field. Okay, that's what Latipov was like. No, yes, we understand you guys are mentioning something like out of sequence in ceiling placement, but field relationship, it does not really support what you guys are stating. Okay. Then, so in the end, also, Maya et al. 2013 provided another model for the origin of stratiform reefs arising in the Bushveld complex. So this study proposed a fundamentally different mechanism for the formation of stratiform reef horizon, e.g. chromatite and magnetite layers. So the study argued that these layers did not form purely by in situ crystallization or crystal settling or fractional crystallization in a static magma chamber. Instead, suggested formation was linked to hydrodynamic processes within the chamber. Specifically proposed that sulfides, chromite, and magnetite were hydrodynamically concentrated. This concentration occurred during the collapse of cumulate layers. The collapse was driven by crustal loading and central subsidence of the magma chamber. So, in conclusion, whether it's the uppers pushing metal up or the downers pulling these metals downward, or even magmas that were already saturated with the sulfides or with the magmatic sulfides from deep within the earth staging chambers. The story of the Merensky Reef is far from settled. It's a geological detective story written in molten rock and minerals, and we are still uncovering these clues. It means further studies, they are also needed to keep on revising this school of thoughts. So one thing is certain, the Bushveld complex holds some of the Earth's best kept secrets. And the more we uncover, the more we study, the more we do research, the more the more complicated we gonna understand the Bushveld complex, or the more difficult it is to understand the Bushveld complex, or the formation of the or the emplacement of the Bushveld complex. So if you love science, mystery, and a touch of the earth ancient power, you are in the right place. Please don't forget to subscribe for more stories beneath the surface. If you enjoyed this lesson into the Bushveld complex, especially the three school of thoughts for the formation of the PG, or for the PG enrichment in the Bushveld complex, you are more than welcome. Please don't forget to like, share, comment, and if you still having some queries, you are more than welcome to comment in the comment section, and I will be pleased to help. Please, thank you guys for joining us today. We are nothing without you. This channel is nothing without you. But the academics, we're gonna not only the academics, but also people in the mining industry. They need to understand a bit about these schools of thoughts. All right. And also not only people in South Africa, but worldwide, because we've got layered intrusions worldwide. All right. Still water complex, and many others. All right, many others. All these things, they need you to understand how the layered or the layered intrusions they came about. Thank you guys for joining us today. And you know what I'm going to say? I would like to say, until next time, cheers.